Good morning, students. Today is the first day, first class, and the first chapter of our chemistry, that is basic concept of chemistry. So, in this class, I will try to give a little idea about the fundamentals of chemistry. That is, what is chemistry? The branches of chemistry. What do you mean by the term matter? Classification of matter. Simple terms like element, compound, mixture, atom, molecule, symbol, valency, formula. How to write a chemical equation and the way to balance it. Let us discuss one by one. First one is chemistry. What do you mean by the term chemistry? It is a branch of science which deals with the study of composition of matter. It is a branch of science which deals with the study of composition of matter and the various phenomena, various chemical reactions involved in it. So various branches of chemistry there. We have to focus only three branches, that is physical chemistry, organic chemistry, and inorganic chemistry. What do you mean by physical chemistry? It is a branch of chemistry which deals with the study of the principle of various chemical reactions. What is the principle behind the various chemical reactions? Next is organic chemistry. It is the study of carbon and covalently bonded compounds which are derived from animal and plant kingdom. Next one is inorganic chemistry. It is a branch of chemistry which deals with the study of elements and their compounds except covalently bonded carbon compound which are derived from non-living organisms. Next, switch over to another term, that is matter. What is matter? Anything around us which has some mass, occupies some space, is known as matter. Then we go through classification of matter. Let us draw a flowchart diagram to identify the classification of matter. Matter has two classifications. One is known as physical classification. One is known as chemical classification. On the basis of physical classification, it is a three. That is, one is solid, one is liquid, one is gas. On the basis of chemical classification, it is of two. One is pure substance, and one is mixture. Again, pure substance classified into two. One is known as element, one is known as a compound. Mixture classified into two, that is homogeneous mixture, and the second one is heterogeneous mixture. Next, element classified into three, that is metal, non-metal, and one is metalloid. Compound is classified into organic compound, Second one is inorganic compound. Mark that. It is the classification of matter. First one is physical classification and chemical classification. That is physical classification, basing upon the appearance. Physical state, three types. Depending upon the magnitude of forces of attraction among the constituent particles. These are three types. One is a solid, one is a liquid, and one is a gas. Solid is one of the state of matter in which they have definite shape and definite volume. And the magnitude of forces of attraction between the constituent particle is maximum. Then gas. The matter in this state neither definite shape nor definite volume. And the magnitude of forces of attraction among the constituent particle is very weak. While third one, liquid. The magnitude of forces of attraction lie in between that of the solid and the gas, where the matter, the substance having no definite shape, it takes the shape of the container where it is kept, but definite volume. It is about the physical classification. Move to the chemical classification. On the basis of chemical classification, one is known as element, one is compound. What is element? It is the simplest form of a pure substance. I repeat again. Element, nothing but the simplest form of a pure substance made up of one kind of atom. Always made up of one kind of atom. It is neither decomposed nor built up from any other substance. Suitable example, hydrogen, helium, lithium, beryllium. It is again of three types. It may be metal, maybe non-metal, maybe metallic. If it is hard and solid, possess high melting point, high good or good conductor of heat and electricity, show the exhibit of malleability, ductility, then they are known as a metal. Iron, copper, nickel, cobalt. If these properties are not observed, known as a non-metal. Hydrogen, oxygen, nitrogen. If this property of a metal and non-metal is shown, then it is known as metalloid. Suitable examples are alloy. Move to the next one, that is known as a compound. A compound is also one classification of pure substance which is made up of two or more type of elements combined together, definite ratio, fixed proportion by mass. Let us consider a suitable example, that is H2O, water. So water may be collected from India, China, Russia. Water may be collected from pond or sea or ocean or tube. Water may be collected by day and night by a man or a woman, from wherever may be, by whomever may be, whatever may be the quantity. In each cases, there is the presence of hydrogen and oxygen in the ratio of 2:16 or 1:8 by mass. If this ratio is not observed, if there is no definite ratio, then it is known as mixture. Suitable example is air. Again, mixture is of two types: homogeneous mixture, heterogeneous mixture. If the various components are not physically distinct, known as homogeneous mixture. If physically distinct, then it is known as heterogeneous mixture. It is a little idea about matter and classification of matter. Next, switch over to another two fundamental terms, that is atoms and molecules. Next we discuss atom and another one is molecule. As it is the first class, I hope all of you know it better. Till I give a little idea about this one. What do you mean by the term atom? It is the simplest form, atom. Atom is the simplest form of a substance. That means atom is the simplest form of an element. Molecule also simplest form of an element. So never confuse. Atom is the simplest form which may or may not exist independently. And in every chemical reaction it is participate. While molecule is the simplest form of an element or a compound, but it always exists independently. I repeat again, molecule is the simplest form of an element or a compound which exists independently. So most important difference between atom and molecule is, it is a smaller person, it is the smallest person. That means, but one thing is that it may or may not exist. Atom is may or may not exist independently, while all molecules exist independently. For example, noble gases, metal atom, they are exist independently, while non-metals not exist independently, while all molecules exist independently. Again, molecule classified into different sections depending upon the number of atoms or types of atom. Depending upon the type of atom, molecule is of two types. One is homoatomic molecule, one is heteroatomic molecule. If a molecule made up of only one kind of atoms, known as homoatomic molecule, O2, N2, H2, O3, these are homoatomic molecules. HCl, NH3, CH4, CO2, H2SO4, these are heteroatomic molecules. Again, molecules are monoatomic, diatomic, triatomic and polyatomic. It may be homo or hetero. If that molecule contains one atom, then monoatomic. If it is two atom, diatomic, three atom, triatomic, and more than that, it is known as polyatomic. These are some examples, little idea about atom and molecule. But most important thing is that in every chemical reaction, atoms will take part in that form, but not a molecule. Next, we go to another 2 to 3 terms. One is symbol, one is valency, one is a radical or ion, and the last one is the formula. Mark that. Next, we will discuss what is symbol, valency, radical, and the formula. Let us discuss one by one. First one is, what do you mean by symbol? It is nothing but the shorthand representation for a long name. I repeat again, the shorthand representation for instead of full name of an element or a compound is known as the symbol. For example, if I say hydrogen, the shorthand representation of an element is known as symbol. So instead of hydrogen, we write H. Instead of oxygen, we write O. Instead of nitrogen, and aluminium, Al. So this symbol may be a single letter, may be a double letter. This symbol may be derived from the Latin name of scientist, name of planet, name of country, so many are there. Again, some transition element is there, they exhibit more than one. That means, in case of transition, mark that is, suppose we say the copper. That is, in this case, it is derived from Latin name, that is cuprum. Cu. That is iron. Another example, iron. It is derived from Latin name ferrum. Sodium. Derived from Latin name natrium. Potassium, derived from Latin name is gallium. These are maybe single, I repeat again, it is a single name or a double name, may be derived from Latin name or or name of scientist, name of country. So it is a little idea about symbol. Next we go to what do you mean by the term valence. So it has two definitions according to old concept and according to new concept. According to old concept, it is nothing but the combining capacity. That means valency of an element is defined as the combining capacity, that means with the number of hydrogen atom or the number of chlorine atom or double the number of oxygen atom of an element combined with other atom. But always it is unable to satisfy the actual fact. So we always use the modern concept, the electronic concept. What is the electronic concept? According to this, the valency is defined as the number of electrons lost or gained or shared in order to attain the nearest noble gas configuration. For example, sodium. So in order to attain its nearest noble gas configuration, it loses one electron. So it's valency 1. In case of chlorine, it will gain one electron in order to attain its noble gas configuration. So it's valency 2. In some cases, especially transition element, they exhibit more than one valency. So that is known as variable valency. Lower valency is known as os. Higher valency is known as ik. For example, mark that. For example, when iron combines with chlorine, it will form FeCl2, it will form FeCl3. That means here is one Fe2 plus and Fe3 plus. Lower valency is known as os, that is known as ferrous. Higher valency is known as ec, that is known as ferric. So we will form two compounds. One is known as ferrous chloride, one is known as ferric chloride. Similarly, copper exhibits two valency, 1 and 2. That is cuprous, one is cupric. Plumbous, plumbic. Stannous, stannic. Mercurous, mercuric. So they exhibit variable valency. Next, we go to another term, that is radical. Mark that. What do you mean by the term radical or ion? It is defined as an atom or a group of atoms having positive charge or negative charge and behaves as a single unit in every chemical reaction. I repeat again. It is defined as an atom or a group of atoms having positive charge or a negative charge and behave as a single unit in every chemical reaction. Again, it is of two types. One is electropositive radical and one is electronegative radical. Mark that. Electropositive radical. One is negative radical. Otherwise, one is basic radical. One is acid radical. Otherwise, one is known as cation. One is known as anion. Mark that. If that atom or group of atom behave positive charge, that is known as electropositive radical or basic radical or cation. If it possesses negative charge, then known as electronegative radical or acid radical or anion. Some examples: Na plus, Mg2 plus, Al3 plus, etc. These O2 minus, N3 minus, OH minus, SO4 2 minus. Again, these radicals classified into depending upon the number of charge: monovalent, divalent, trivalent, polyvalent. Monovalent, maybe it is positive or negative, 1 plus or 1 minus, then it is known as monovalent radical. 2 plus or 2 minus known as bivalent radical. Trivalent radical is polyvalent radical. It is little idea about radical or ion. Next we will discuss how to write a formula. What is a formula and how to write a formula. Next we discuss what is formula, how to write the formula. Means what are the different steps we have to follow for writing the formula. First we discuss what is a formula. It is a shorthand representation. Instead of writing the full name of an element, it is a shorthand representation. For example, height. That means while writing the shorthand representation for a molecule or a compound, we write with the help of symbols and subscript number. That is known as the formula. I repeat again, formula. The shorthand representation for a molecule or a compound which is represented in the form of symbols and subscript number. That is known as formula. Then question arises, is there any rules we have to follow for writing a formula? Yes, mark that. What are the rules? First, write the cation first, followed by anion. Point 2, assign their charges at their right hand side top. Next, put a bracket if a compound radical is present. Next, take a common to their valency. Last one, cross their valency. Mark that 3 to 4 point is there. First, write the cation first, followed by the anion. First we write the basic radical, then acid radical. First we write the positive ion, next negative ion. Step 2, assign their charges at the right hand side top. Third step, if their compound ion is there, compound radical is there, it may be cation or anion, put it in bracket. Next step, if there is any common to their charges, common to their valency, take a common. Last one, crisscross. Let us apply this one, writing some formula. First one, sodium carbonate. We write sodium carbonate, put it in bracket, assign their charge. As there is no common, then finally crisscross. This one goes to here, this one goes to here. There is Na2CO3. Second example, calcium chloride. Mark that. Calcium, chlorine, put their charge, no common, crisscross. That is CaCl2. Next, aluminium nitrate, that is aluminium Al nitrate NO3. Take a common, that is put a bracket, compound radical, give the charges, no common is there, crisscross, that is Al NO3 thrice. Next, calcium. Next to discuss another some example. Calcium carbonate, mark that, CaCO3 as compound radical, put it in bracket, assign the charge, so take a common, 2 take a common, cancel out, then crisscross, CaCO3. Next, sodium phosphate, that is MaPO3, put it in bracket, PO4 phosphate, put it in bracket, assign the charge, no common, crisscross, that is Na3PO4. Next, zinc carbonate, zinc Zn carbonate CO3, compound radical, put it in bracket, 2 plus, 2 minus, take a common, then crisscross, ZnCO3. These are some simple examples of writing the formula. Next is over to what is chemical equation and how to write the chemical equation. Next we discuss what is chemical equation and how it is balanced. First we discuss what is a chemical equation. The true chemical reaction going on, which is represented in the form of symbols and formula, is known as chemical equation. I repeat again. A true chemical reaction which is represented in the form of symbols and formula is known as chemical equation. It is of two types. One is balanced, one is not balanced or skeletal. In writing chemical equation, it has two components. Left side known as reactant, right side known as product. Reactant may be a single term or more than one term. If more than one term is there, each term separated by a plus sign. Similarly, product side may be a single component or more than one component. If more than one component are there, they are separated by a plus sign. And the reactant and the product is separated by giving an equal sign or one arrow mark. Again, the different phases of the reactant and product we also mention by giving symbol. If it is solid, then we substitute, we write S, liquid L, gas G. And also, if precipitate is there, then we put arrow mark down. If gas is there, put arrow mark up. Again, reaction are of two types. One is a reversible reaction, one is not reversible or irreversible reaction. In case of reversible reaction, we write half-headed both sides. If not reversible, only one side arrow mark. What do you mean reversible? Means when the reactant react to form the product, simultaneously product decomposes to the initial reactant, then it is known as the reversible reaction. Represent this side. On the other hand, when the reactant react to form the product, but the reaction never backward, then it is known as not reversible or irreversible reaction. It is represented by giving scintillate. Mark that some examples. N2 gas plus H2 gas give rise to NH3 gas. Point 1, point 2, Cl2 plus NH3 give rise to N2 plus NH4 Cl. Mark that. I write two equations. Chlorine gas, solid. Another example. AgNO3 plus NaCl give rise to AgCl plus NaNO3. This is known as precipitate. Mark that. Some examples is there. Here G stands for gas. Double-headed arrow mark stands for reversible reaction. Here downward arrow mark stands for precipitate form is there. So different type of reaction and symbol is there to represent their physical state. And while writing the reaction, it may be balanced form or may be skeleton form, not balanced form. What do you mean by skeleton form? That means each kind of atom on LHS, if is not equal to the RHS, then it is known as not a balanced reaction or skeleton reaction. On the other hand, if each kind of atom on LHS is equal to an RHS, then it is known as balanced reaction. As we are studying the first year science, now in the starting we only focus to only one type of method to balance this one, that is heat and trial method. What is heat and trial method? That means we have to multiply the suitable integer on reactant side to each term and also the product side till the total number of each kind of atom on LHS is equal to an RHS. That is known as balanced one. Let us observe one by one. So nitrogen atom total number is 2, it is 1. That means it is a skeleton reaction we have to balance. Mark that. N2 plus 3H2 gives rise to 2NH3. Now each kind of atom on LHS is equal to RHS, so it is no balanced equation. Mark that. 8NH3 plus 3Cl2, N2 plus 6NH4Cl. Now it is known as balanced reaction. Now it is already balanced, so it is known as balanced reaction. So I repeat again, a reaction, chemical reaction are of two types. One is not a balanced, known as a skeleton reaction. One is a balanced reaction. And we have to balance. Balanced reaction means total number of each kind of atom on LHS is equal to RHS. For the timing, we have to follow one method that is known as heat and trial method. What is heat and trial method? Multiply suitable integer to each term till the total number of each kind of atom on LHS is equal to the RHS. It is little idea about chemical reaction and how to balance